you think that these three, B, F, and F, Bayesian, Fiduciary, and Frequentist, should be BFFs forever. They should be best friends forever. So why do you say that?
Well, it's a great question, and the reason I say that, and also my BFF community colleagues, is because we all kind of went through these different perspectives. We try to convince ourselves which one is the best. We end up realizing we really need all of them because each one of them have something to offer, and each one of them has its own weakness. And in fact, I come to a conclusion. This is part of saying I'm trying to do this more foundational thinking, that I don't think we will ever settle which one is better, because fundamentally, anytime you do anything about data science, right, there is a leap of faith involved. But let me explain what what that means. This is part of the reason why thinker philosophy is so important for thinking about the data science itself. But you have to ask yourself, anytime I have the data, and I'm asked to use the data to predict something which nobody knows for sure, because if they do, then we don't need to do the prediction. What makes possible to go from the data to whatever this thing I want to know, right? Logically, why would that be even possible? What's the part of nature, or if you believe God, which part of the God that allows us to do that, right? So basically, the every school, and that's why lots of philosophy involved, is thinking about what are the links between what we know and what we don't know, right? And in this process, that these different approach, the perspective I just talked about, is all trying to use the mathematics to help us to make the link, to make that connection, right? And I can tell you what's a problem with each one of them, and why I'm in the end, and I think increasingly more people realize we should use all of them. First, we started as a frequentist, like myself, right? But eventually, the Bayesian convinced me that the frequentist has one fundamental flaw, which is that, yes, you can study all these beautiful answers, tell me on average something works. But in the end, right, even you tell me that medication has 95% chance work for you, right? Well, there's still 5% chance that it doesn't work for me. And the 5% in the population is a huge amount of people, right? And how do I know I'm not the 5%? Like, how do we know this average answer is relevant to me? So the frequentist one forever suffer this could be completely irrelevant, right? Just for me. So then we go to the Bayesian answer. The Bayesian answer is obviously, well, it will be very relevant for you, okay? Because that's how it is set up. But the problem is you need to make lots of assumptions in order to get an answer. And the question is, how do I know these assumptions themselves are reliable, right? Now, there is a school called objective Bayes. The idea is, can I use a prior knowledge, which people call a non-informative prior? Can I assume, basically say, I'm very ignorant and use that school? Now, if that can happen, that'd be wonderful. But it turns out, this is the fatal thing about the Bayesian statistics. Bayesian statistics, there's no way you can put down a prior which is truly ignorant. Probability distribution does not allow you to model ignorance. Because anytime you put down a distribution, people say, well, let's assume like everybody equal chance. No, equal chance is not being uniform, not being ignorant. Equal chance is a huge amount of information, right? Anytime you put down a distribution, it will ask you to specify the relevant frequency of two different states, right? So you have to do that. So it turned out the problem with Bayes, I've been using this phrase, because thinking about doing mathematics without the concept of zero. Because in Bayes, there's no zero information. You always have to assume something, right? So that's where now I started moving to the Fiducial, because Fiducial said, we want to do the inference, but without making any assumptions, without a prior, essentially like the zero information. And they can do that. But it turned out that because the zero requirement, it turned out that how do you operate? How do you, using in the Fiducial framework, or more generally, there is a whole area called imprecise probability. The imprecise probability is exactly trying to address the issue. The probability itself is too precise, because the probability itself still need to specify the relevant frequency. Sometimes I just know the answer between 3 and 5, but don't ask me Like how likely is 4 compared to 2.5? I don't know. I know the answer between 3 and 5. How do you model that? And that one, the Bayes probability cannot handle that. So the imprecise probability is trying to handle that kind of thing. But it turned out, I just wrote another article recently, when you do that, you still have to make a judgment how you want to update the information. Like in Bayes framework, you have a Bayes zero to tell you how to update the information, right? There's a clear rule. But broadly, when it goes to this imprecise probability, you have a variety of different rules. It depends on whether you're an optimistic person or you're pessimistic or you're opportunities. Like these different perspectives will give you different rules, give you different answers. So then I realized, okay, now see, every school has problems, right? Every school, either you get answers not that relevant, or you need to make lots of assumptions, or you still need to make some judgment. So the thing in the end, you realize that all schools, they're all trying to do the right thing, but they all come up with different answers. And not because they have defect just for the sake of having defect. It's because if you think of fundamentally what makes possible to make prediction of the future, I think there's just a fundamental problem is there's no simple answer here. And that in the end, just like the whole data science itself, we basically have to use whatever the methodologies, all can help. But we need to be aware of the limitation of each one of them, and we understand where you're going to suffer if you use it in not in the right way. That's why I think we should all use all of them.